Section 2.4 is about average rate of change. Okay, average rate of change is the same concept as slope. If you have a linear function, a line, x to the first power, your slope is constant. So if I have like y equals 2/3 x minus 1, what is my slope for this line? The 2/3.
2/3.
So that means I'm going to plot this point at -1, and then I'm going to go up 2/3, put a point, up 2/3, put a point, up 2/3, put a point. Your slope is constant when you have a linear function. Any other time you have a function and they ask for the average rate of change, you use the slope formula. All it is the change in x, the change in y over the change in x, but it's not going to be the same between every point. Like look here, if I say at this point here between 1 and 2, this is going to be a certain value. But if you look between 2 and 4, do you see how it slopes up a little faster? So what you're going to do is you're going to be given either a function or some x values. You plug in to find the y. Then you find the average rate of change by using the slope formula. You should be able to tell if your answer is right if you look at the average rate of change, the sign of it. Now think of this. What is this function doing the whole time? Is it going up or is it going down?
Is it going up?
It's going up. It's increasing the whole time. So when you do the average rate of change or the slope, you should get a positive answer. So if you look here, they talk about the distance traveled, which was the y-axis, over the time, which was the x-axis. All they did was take the slope. Look, 4 minus 1, right? The s of 4, so it was 200 minus 50, and then 4 minus 1, that's where we got 50 miles per hour. So let me just show you. Here is the average rate of change formula. It looks exactly like the what? What other formula does it look just like? What does this formula look just like, guys? Nobody has any idea? It's exactly how you find slope. y2 minus y1 over x2 minus x1. That's what we're finding here. When they talk about the net change, that's going to be on your web assignment. It says the expression for average rate of change, the numerator is the net change. That means your change is in what? Is it your change in y or your change in x? What's in the numerator? Guys, what does that say right here? Change in what? In the numerator. Change in what? Okay, so net change. When they ask for net change, they're asking for the change between y values. All right, so let's problem. All right, here is this function. All right, they gave us this function on a graph right here. They're asking us for the average rate of change and the net change between the following points. Okay, the average rate of change and the net change. So if I'm going to do letter A, they're giving me two x values to look at. X equals 1 and x equals 3. So I can go over here to my picture and I can say, okay, when x is 1, what is the y value? When x is 3, what is the y value? Or I can calculate it given the function. I can plug in x. If I plug in x here, if I say plug in 1, 1 minus 3 squared. What's 1 minus 3? Negative 2.
Negative 2.
Good, and then I have negative 2 squared, which gives me what? 4. So I have the point 1, 4. And then if I plug in 3, 3 minus 3 squared. What's 3 minus 3? 0, and 0 squared is? So when I plug in 3, I get out 0. So if they want to know what the net change is, remember, net change is what? Change in y's or the change in the x? Just talked about it. Just
Positive 2 and negative 4.
Well, the net change would be the changes in the y. So your net change would be 4. When they ask for the average rate of change, you use the slope formula. So I'm going to say 0 minus 4 over 3 minus 1. What's 0 minus 4?
4.
Negative 4. And what's 3 minus 1? 2. So the average rate of change is negative 2. It's very important that you guys have that negative, because what is happening between this point here and this point here? What is my function doing? It's going which direction?
Up.
We read from left to right. So from here to here, your function's going up or down? It's going down. So that's why it's negative. When they asked for the average rate of change between these other 2 points, well, they gave me x values of 4 and 7. So plug in 4, see what you get. Plug in 7, see what you get. So if I plug in 4, I have 4 minus 3 squared. 1 squared is 1. Now I'm going to say 7 minus 3 squared, which is 4. 4 squared is 16. So if I find the net change, that's the change in our y's, the net change would be 16 minus 1, which is 15. The average rate of change would be 16 minus 1 over 7 minus 4. So 16 minus 1 is 15 over 7 minus 4 is 3. The average rate of change is 5. Does that make sense? From this point to here, what is my function doing? It's going in which direction? It's going up. So what you need to see from this is they gave me two different sections to look at, and their average rate of change was not the same because it's not a constant function. So if all they do is give you a picture and they give you x values, then on the graph you have to find the y values, and then you find the net change is the change in y's, the average rate of change is your slope formula. If they give you just a function and they give you x values, plug the x values in, find your y, and then do the same thing. So if I look at the next slide, this is the function that they gave us. They didn't give us a picture, they just gave us a function. So if I do letter A, okay, I'm going to plug in 0 into this, and I'm going to plug in 1. So when I plug in 0, I have 3 times 0 minus 5. Gives me negative 5. Now I'm going to plug in 1. 3 times 1 minus 5 gives me negative 2. So my average rate of change here would be negative 2 minus negative 5 over 1 minus 0. This is my rate of change. So I have 3 over 1 for letter A. Now I'm going to do the same thing for B. And I'm going to plug in for B, I'm going to plug in where x is 3 and where x is 7. So I say 3 times 3 minus 5. 9 minus 5 is 4. Now I say 3 times 7 minus 5. 21 minus 5 is 16. Agreed? So if I did my average rate of change, that's just slope, 16 minus 4 over 7 minus 3. I get 12 over 4, which is 3 over 1. What do you guys notice about the slope for A and the slope for B?
They're the same.
They are the same. What kind of a function do I have here?
Linear.
It's linear. What did I just talk about? When I have a linear function, their slope is constant, right? So you can look at a function and you can find the average rate of change between several points, and you can tell if it's linear or not. Because if you have a linear function, every time you do the average rate of change, you should get the same answer. If you have a quadratic or something cubed or square root, something like that, your average rate of change between different points is going to be different. So what you guys are going to do on your web assign, they're going to ask you for net change. Write this down if you didn't before. When they ask for net change, that means the change in what value? Good, change in y value. When they ask for the average rate of change, they're asking you to use the slope formula. I say slope in quotes because what they want is the change in the y over the change in the x, and you use the same method that you would, y2 minus y1, x2 minus x1. But we don't call it slope because it's not a line. But these are the two things that you're going to have to do tonight on your homework on your website.